So you can see. Just check whether recording is going on or not. So yesterday we have studied this example, right? That is of homogeneous equation with the conditions. Okay. So one example I given it for homework. Have you completed this? Anyone please? This homework example, anyone tried? Hello? 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 I'm audible? Yes, anyone please?
Yes, sir.
Okay, fine. So we will study the specific forms of the particular integral. Okay. So there are type 4, I said, type 1, type 2, type 3, type 4. Okay. So first type, that is if the RHS instead of 0, if exponential function is coming, instead of 0, if exponential function is coming, what we have to do it. Okay. So whenever an exponential function is coming, for example, you can see this. Whenever an exponential function is coming, divided by f of d. F of d in the sense, you know that is entire thing is a function of d, and that we have collected earlier. Okay. If the RHS is an exponential function, in that case, directly what you can do is that in f of d, replace d by a. In f of d, replace d by a. That is there in the denominator. So d we have to replace it by a. If the denominator is not equal to 0, you stop there only. If denominator is equal to 0, anything divided by 0 leads to indeterminate form, or else it leads to undefined quantity, or else anything divided by 0 will be infinity. So whenever the denominator is coming 0, whenever denominator is coming 0, if denominator is not coming 0, stop here only. If denominator is equal to 0, you may ask that, sir, whenever denominator is equal to 0, what we have to do it? So whenever denominator is equal to 0, so what you can do is that multiply it by independent variable. Please identify dependent variable and independent variable. So for example, if dy by dx is there in the equation, so this is a dependent, this is independent. I told that whenever denominator is equal to 0, please try to concentrate on the second condition. Second condition. So that is whenever denominator is equal to 0. Okay, so we have to multiply it by independent variable, because here independent variable is x. If the independent variable is t, so try to multiply it by t. If the independent variable is z, try to multiply it by z. It doesn't mean that always we should multiply with x only. That is wrong concept. You can see the independent variable. Okay, so next. So multiply it by independent variable. So as usual, that is, you can see here, e raised to ax divided by, so what is the denominator there? No, f of a, that you have to differentiate. That is f dash of a. So f dash. So f dash means, so whatever, this is a f of d. Whenever you are differentiating this, you are getting f dash. If you are differentiating f, you are getting f dash, and again d is replaced by a. At the point a, always at the point a, you have to check it. What do you mean by this a always? What do you mean by this a? A is this e raised to ax. So this value of a we have to replace in the denominator. In the denominator, especially where f of d is there, I had to replace, and I had to remove completely d. I don't want in the equation I don't want any kind of D over here. D should be completely replaced. Okay, even some other of D are coming. So in the example, you'll come to know what exactly we have to do it. Okay, now presently you understand only that D, whenever RHS is of exponential function, so D is replaced by A. What is that A? The A is exponential function is there, no? This X coefficient is A. Okay, if the denominator is not equal to 0, stop there only. If the denominator is equal to 0, multiply it by independent variable e raised to x divided by derivative of f of d at the point A. At the point A. Again, if denominator is not equal to 0, stop here. Otherwise, further you continue. That is, again you multiply it by x, e raised to x, differentiate f double times. Differentiate that f of d double times at the point A. Again, if it is not equal to 0, stop. Otherwise, the process will continue like that only. So understood this, whenever RHS means, whenever RHS is exponential function, so D is replaced by A. D is replaced by A. If the denominator is not equal to 0, stop there only. If the denominator is equal to 0, if the denominator is equal to 0, I have to multiply it by every time independent variable and I have to differentiate the denominator. That much you keep in mind. Okay, so any doubts? Any doubts? Hello, students. Hello.
No, sir.
Okay, fine. So note. So here, some of the things we have to convert it. Okay, some of the things we have to convert it in terms of an exponential function. If these things are coming, please try to convert it to an exponential function. It is possible. That I'm giving well in advance. So for example, if k is any constant, if k is any constant, then k can be written as k into e raised to 0 into x. E raised to 0 into x. 0 into x will be 0. E raised to 0 will be 1. 1 into k will be k. So total value remains the same. For example, instead of k, 2 is coming. So 2 can be written as 2 into e raised to 0 into x. So e raised to 0 into x. This is 0. E raised to 0 will be 1. 2 into 1 will be 2. So we are not affecting anything, just we are modifying the given equation. This is what one adjustment we have to do it whenever the constant terms are coming. Okay, the constant in general I had taken it as k. So next coming to a raised to x. If a raised to x is coming, how to do it? How to do it? Okay, so this directly you can take e raised to log of e raised to x. See, we want some of a raised to x, right? Log and exponential function, always they cancel each other. When these two will cancel, what is remained here? A is remained, raised to x is remained. So total value remains the same. Is it right? So whenever a raised to x is coming, please try to write it as e raised to log of a raised to x. So the same thing you can see here. I can convert in terms of exponentially. That is you can see e raised to log of a into x, the coefficient of x, that is log of a. So for example, 2 raised to x is there. So the same thing I can write e raised to log of 2 raised to x. So that is nothing but I can write e raised to log of 2 into x. Okay, this cancels. 2 raised to x remains as it is. 2 raised to x remains as it is. So therefore, please try to understand these adjustments. Next, whenever an hyperbolic function is coming, sine hyperbolic of ax, so such things I can write it as e raised to ax minus e raised to minus ax divided by 2, because we want an exponential function first. So later in type 2, type 3, type 4, some other forms are coming, but basically how much, as much as possible, I want to convert in terms of exponentially. If it is not possible, I'm going for some other alternative methods that we are studying later stage. Next, come to cos hyperbolic of ax. So that is e raised to ax plus e raised to minus ax divided by 2. These are the formula so that I can convert in terms of exponentially. So next, e raised to ax plus b is coming in the sense. See, whenever base is same, I can separate the powers. So that is e raised to ax plus b can be written as e raised to ax into e raised to b. So here e raised to b acting as a constant because it is not involved with any variable. So e raised to ax. So the coefficient of xe, this I can replace when the process starts. So these are the few adjustment I had to do it. So next you can see, we'll solve the examples. Please try to concentrate on those examples. So that is, let us go for the first example. So you can concentrate here. Solve 6d square y by dx square plus 17 dy by dx plus 12y is equal to e raised to minus x. Here dy by dx is, I told you, identify dependent variable and independent variable. So here y is a dependent variable, x is an independent variable. So as usual, process continues. So earlier that whatever we are doing in the complementary function, we have to do the same thing. Only getting particular integral will be varying. So that is 6. This is d square y, 17 d of y plus 12y is equal to e raised to minus x. So here y is common, 6d square plus 17d plus 12 into y is equal to e raised to minus x. As earlier RHS was equal to 0. Earlier RHS was equal to 0. Now RHS is not equal to 0. Okay, so because of that, it is called as non-homogeneous equation. If the RHS is equal to 0, it is called as homogeneous equation. So here RHS means this quantity is not equal to 0. So it is non-homogeneous equation. So I told you, whenever non-homogeneous equations are coming, in addition to complementary function, we are finding the particular integral. So that I'll write, that is y is equal to complementary function plus particular integral. So that is capital D should be replaced by m. That is 6m square plus 17m plus 2 is equal to 0. So here I'm replacing everything capital D in terms of m. M means some other variable we have to, even you can take other than m, no problem. But as a rule, okay. So I'm taking every time m only. So I'm taking here also m only. So it is 6m square plus 17m plus 12 is equal to 0. So friends, look out here, 12 into 6. By multiplication, we want that much. By addition or subtraction, I want 17. Okay. So you can see here what are the factors over here. The factors are 12 into 6, 72. So 8 into 9. So 8 into 9, how much? 8, 8, 16, 16 plus 1, 17, 17m. That will be there here. And this is 72m square that I'm getting. Okay. So this is what the four factor here. And between these two terms, what is common? You can see 6 and 8 is there. So 2 is common. M square and m is there. M is common. So inside what is remained? That is 3m plus 4. And here 9 and 12 is there. So it is very common thing that 3 is common. So 3 is common. 3m plus 4 is equal to 0. So see, always we should get one term should be common. I told in the beginning, right? So 3m plus 4, 3m plus 4 is common. So 2m plus 3, this is 2m, plus 3. Okay, this is one root. So we are getting 2m plus 3 equal to 0 is one root, 3m plus 4 equal to 0 is one root. So 2m equal to minus 3, m equal to minus 3 by 2. 3m equal to minus 4, m equal to minus 4 by 3. Here you can just check out. Roots are real. And different. See, there is no as such thing that minus values are coming, but I is not coming. So whenever I is not coming, so then the root is real only. So minus 3 by 2 minus 4 by 3. So roots are real and different. Whenever roots are real and different, how to write the complementary function? That is c1 e raised to minus 3 by 2x plus c2 e raised to minus 4 by 3x. So I got the complementary function. Till here, it was a common for you people. Now, getting the particular integral is very important. I told that. So in the particular integral, we want particular integral is equal to e raised to ax divided by f of d. So what is this f of d? What is this e raised to ax? That everything we will study here. So this is e raised to ax. This divided by f of d. That is e raised to minus x divided by of this. E raised to minus x divided by this. So e raised to minus divided by this. So this is just compare. Who is that, please? Srikanth? Okay, so this is this entire thing you can see. This is okay. E raised to ax divided by f of d. It is looking like e raised to ax divided by f of d. I told that whenever e raised to ax divided by f of d is coming, so it is exactly looking like e raised to ax divided by f of d. So the coefficient of x is called as a. Coefficient of x is called as a. So a is minus 1 here. And whenever an exponential function divided by f of d is coming, what the rule says? Rule says that replace d by a till to get denominator as non-zero. So you can see here d is replaced by a, d we will be replacing by minus 1. So e raised to minus x divided by 6 into minus 1 the square plus 17 into minus, see wherever d is there, replace it by a is nothing but minus 1. So 6 into minus 1 the square plus 17 into minus 1 plus 12. So e raised to minus x. So minus 1 the square is plus 1. So 17 into minus 1 is minus 17. So 12 plus 6, that is 18. 18 minus 17, that is 1. See, denominator is not equal to 0. Stop the solution here only. So e raised to minus x divided by 1 will be e raised to minus x. This is what we have to get it the particular integral. So here only denominator is equal to 0. If here only denominator is equal to 0, I would have multiplied it by x and I would have continued. But here it is not so. So now what I will do is that, so you can see this complementary function and particular integral, I'll write it together with a plus sign. So you can see here. Therefore, our solution is y is equal to complementary function plus particular integral. Plus particular integral. So that I have written, you can see. So that is, this is what the complementary function, right? This is what the particular integral is. Okay. So any doubts? Hello? Hello, students, any doubts?
No, sir.
Okay, fine. So I'll search a simple example because time is 10:24, another 15 minutes. So which example I can solve? Simple example. Okay. So anyway, I'll solve that example only. Remaining, if it is remained, I'll give it for homework, no issues.
Sir, please explain once again that finding the particular integral.
Yes. Once again. See, till here you understood, right?
Yes, sir.
Okay. So particular integral means, so this exponential function divided by this is called f of d. So this divided by this we have to write. That I have written it. Correct?
Yes, sir.
Okay, fine. So next, how it is looking? How it is looking? This is looking like e raised to ax divided by f of d. Correct? So whenever this is coming, this is a type 1. So d is replaced by a. So here just compare this one and this one. A means what here? Minus 1. Right? D is replaced by minus 1. D is replaced by minus 1. So that is 6 into D is here. See here. D is here. Minus 1 the square plus 17 into D means minus 1 plus 12. E raised to minus x divided by 6 into minus 1 the square plus 17 into minus 1 plus 12. So 6 minus 17 plus 12. So 12 plus 6, 18. 18 minus 17 will be 1. So denominator is not equal to 0. Denominator is not equal to 0. It is other than 0. If other than 0 is coming, you stop the solution. When you simplify this, it is e raised to minus x. It is e raised to minus x. Understood this?
Yes, sir.
Okay, fine. So next, coming to solve y double dash plus 2y dash plus y is equal to cos hyperbolic x by 2. So as usual, you can do here. So that is d square y by dx square plus 2 dy by dx plus y is equal to. See, I know that only an exponential function. Other than exponential function, I don't know anything here. So because of that, so what I will do is that there is a source to convert hyperbolic function in terms of an exponential function that you have studied here. So see, cos hyperbolic of ax is there. Okay, so a is 1 by 2 there into x. So e raised to 1 by 2x plus e raised to minus 1 by 2x divided by 2 I have to write. So a is 1 by 2 there. So the same thing I'm writing, you can see here. See here. A is 1 by 2. E raised to ax plus e raised to minus ax divided by 2. So that I'm writing here. Understood this? Hello? So this
Yes, sir.
1 by 2. 1 by 2, I'll take out e raised to x by 2 plus e raised to minus x by 2. There are two exponential functions now. So, which is, see, as RHS is not equal to 0, this is not equal to 0. Okay, so therefore it is called as non-homogeneous differential equation. It is called as non-homogeneous differential equation. Therefore, y is complementary function plus particular integral. Okay, so complementary function as usual, that is this, replace it by capital D by m square plus 2m plus 1 equal to 0, m square plus by addition or multiplication. See, by multiplication, I want m square. By addition or subtraction, I want 2m. So the factors are m plus m. M into m square, right? So m square plus m plus 1 equal to 0. So between these two, m is common. M plus 1. Between these two, 1 is common. M plus 1 equal to 0. So m plus 1 equal to 0, m plus 1 equal to 0, m equal to minus 1, m equal to minus 1. So m equal to minus 1, roots are complex and repeated. So whenever roots are complex and repeated, okay, so what the rule? What the rule? Whenever roots are, sorry, here roots are real. Minus 1 and minus 1. Roots are real here and they are repeated roots. Whenever roots are real and repeated, okay, so what the rule I had to write? This is what the rule is, right? C1 plus C2 of x, 2 times it is repeated, e raised to mx, m is minus 1 here. So please try to simplify it and write it. So complementary function is C1 plus C2 of x into e raised to minus x. Next, the particular integral is, you can see this divided by this, divided by this. So particular integral is 1 by 2. So I'll write this divided by f of d. It is for my convenience. So e raised to x by 2 plus e raised to minus x by 2 divided by d square plus 2d plus 1. So here there are two exponential functions are there. So what I will do is that 1 by 2, throughout it is a constant quantity, keep it out only. So e raised to x by 2 divided by this f of d, plus sign is there, e raised to minus x by 2 divided by f of d. I can write it like this. I can write it like this. Correct. Yeah? So here what I had done, this divided by this plus this divided by this I written. Okay. So next, therefore, I'll take first one as P1, next one as P2. I'll solve it and I'll substitute in equation 2 afterwards. So let us take P1. P1 means some particular integral. So some symbols I'm giving for our convenience. P1 is what? E raised to x by 2 d square plus 2d plus 1. So friends, you tell me now how it is looking. So this is e raised to ax divided by f of d. E raised to ax divided by f of d. So try to find out e raised to ax. So x is there, fine. A means what? 1 by 2 here. So whenever an exponential function is there in the numerator, so what I had to do, the rule says d should be replaced by a. So a is 1 by 2. So d should be replaced by 1 by 2. D should be replaced by 1 by 2. So numerator as it is. Okay, only denominator. So 1 by 2 the square plus 2 into 1 by 2 plus 1. 1 by 2 the square is 1 by 4. 2 get cancelled. So 1 plus 1. So take the LCM. 4. Here 4. Here 4. 4 plus 4, 8. 8 plus 1, 9. So it is 9 by 4. So 4 goes to the numerator again. Make it reverse. So divided by 9. So what is P1? P1 is 4 by 9 e raised to x by 2. Next, come to P2. So again, how it is looking? E raised to ax divided by f of d. So what is a here? Minus 1 by 2. So d is replaced by a, d is replaced by minus 1 by 2. So d means what? Minus 1 by 2 the square plus 2 into minus 1 by 2 plus 1. So 2 get cancelled here. Minus 1 by 2 the square means what? 1 by 4. So plus minus 1 plus 1. Minus 1 plus 1 get cancelled. E raised to minus x by 2 divided by 1 by 4 is remained. So denominator somehow is not equal to 0. If it is equal to 0, rule will be different. So here in both the cases, denominator is not equal to 0. So because of that, I'll stop the solution and 4 I'll send it to the numerator. This 4 I'll send it to the numerator. It becomes 1 by 4 becomes, when 4 goes to numerator, 4 into e raised to minus x by 2. So the particular integral I got both. This is P1 and this is P2. So this P1 I had to substitute here. This P2 I had to substitute here. So therefore, equation 2 becomes particular integral is equal to 1 by 2 P1. P1 is 4 by 9 e raised to x by 2 plus P2 is 4 into e raised to minus x by 2. So this is what the particular integral. So always correct answer is, whenever non-homogeneous equation is there, the correct answer is writing complementary function and particular integral together. Writing complementary function and particular integral together. So that is, this is P1 and P2. Substitute P1 and P2. I have substituted, and whatever the simplification, 2 ones are 2 twos are, that minor simplification you do it. Again 2 ones are 2 twos are, right? So this is what, after simplifying you are getting this answer. This and complementary function you write it together. So this is what complementary function, this is what particular integral. Writing together will constitute the general solution. Any doubts? Hello? Hello students, please respond, because I want your sincere feedback. Hello?
No, sir.
Okay, fine. So next we'll come to the third example. So that is x triple dash of t minus 8x of t 1 minus e raised to t the square. See here, x is a function of t. X is a function of t. So please try to remember. So we are writing x should be differentiated with respect to t. So I'm writing dx by dt or d square x by dt square. So please try to remember here x is a dependent variable, t is independent variable. So what I am doing is that x triple dash of t, d cube x upon dt cube minus 8 of, see there is no derivative here, x of t, only write it x. So minus 8x is equal to a minus b the square. So a square plus b square minus 2ab. So I'm using a minus b the square formula. Okay, so that is d cube of x minus 8x is equal to 1 plus e raised to 2t minus 2 e raised to t. So x is common. D cube minus 8 into x is equal to 1 plus e raised to 2t minus 2 e raised to t. So which is non-homogeneous differential equation. Okay. So x is equal to, always solve for x, complementary function plus particular integral. See here, write the auxiliary equation, m cube minus 8 equal to 0. M cube minus 8 equal to 0, don't make it as m cube is equal to 8, m is equal to, so the normally students, what they write, yours is correct. I don't want to say it is wrong. So m cube is equal to 2 cube, m is equal to 2. M is equal to 2. You are getting only one root, but here it is a cubic equation. It is a cubic equation. I told you in the beginning. So in the polynomial, what is the highest order? Those many roots you have to get it. So in this polynomial, highest order is 3. Highest order is 3. So you should get the 3 roots. But in the exam, the student m equal to 2, they'll get it fine. It is correct. Only one root you are getting. Another 2 roots, you should get it. Another 2 roots, we should get it. So that is m equal to 2. 2 cube minus 8 equal to 0. So that is, the equation should reduce to 0. Okay, here it is reducing to 0. So m is equal to 2 is a 1 root. So you can write the coefficients now. So m cube coefficient is 1. M square is not there, 0. M is not there, 0. So minus 8. So in this equation, you can see m cube coefficient is 1. M square is not there, write it 0. M is not there, write it 0. Constant term is minus 8. So here, don't write anything. 1 into 1, 1. So 1 2 is a 2. 0 plus 2 will be 2. 2 2 is a 4. 0 plus 4 will be 4. 4 2 is a 8. Minus 8 plus 8 will be 0. Always at the end, we should get 0 in the synthetic division. So now, you can see here, earlier it was a cubic equation. Earlier it was a cubic equation. Now it is reduced to the quadratic equation. How to write it is that 1 into m square plus 2 into m plus 4 equal to 0. By addition or multiplication, I want, by multiplication, I want 4. By addition or subtraction, I want 2m. So roots are not possible. So because of that, go for the formula, that is quadratic formula. So that is there here. That is there here. So, okay, minus b plus or minus square root of b square minus 4ac divided by 2a. So please try to substitute, okay, and get the answer. So this everything, I'll explain it in the tomorrow's class, because another 1 minute is there. It's not possible to explain. It's okay. So any doubts, please try to see the notes. I'm sending it. Try to see the notes. I'll explain it tomorrow. Okay. Any doubts? You're most welcome. Any doubts?
No, sir.
Okay. We will continue in the tomorrow's class. Okay.